Welcome to this session of the Big Mountain Data and Dev Conference. This is stream processing like you've never seen before. Viktor Gamov, who is a developer advocate at Confluent, will be our presenter this session. And Viktor, I'll turn it over to you.
All right, thank you very much. Thank you. It's really exciting to be here and going at you live from not so sunny New Jersey. Usually it's much sunnier, much nicer. But you know, whatever we have. And today I'm going to be talking about some of the things that I like to talk about. Is obviously it's a stream processing let me turn out some slides, and it would be heavily live coding session. Slides here, just the setting context. I cannot just like dive in if you never heard anything about the stream processing or Kafka or whatnot, but in some housekeeping items. So my name is Viktor. As was mentioned, I work as a developer advocate, and as part of my job is building highly scalable and highly available Hello World applications. That's how I usually describe the world to the world, like work that I do. And I came from the consultancy world, and I've seen how the people building apps using all sorts of open source technology. And today specifically, I want to talk about two exciting pieces of open source: is Apache Kafka and Spring Boot. These two technologies, they play very nicely together. We're rather talking about this as like you have a peanut butter and jelly sandwich, and you want to put like extra layer or some sweetness. Like you can put the Spring Boot on top of peanut butter and jelly, which is Kafka and Kafka Streams, and the Spring Boot will make this everything more perfect. But like before we jumping into this one, let me set some context, like for for the people who want to learn how to do practical stuff, but they maybe don't know like why you need to do this. This is not Kafka 101 session. For those of you who joined us today, there are some materials that I will share at the end, so make sure to stick to the end, and I will show some materials that you can learn if you're just starting here. It's more like how you can do things with Kafka rather than just like what Kafka is. So, but essentially, I'm going to be talking about the thing called stream processing or streaming, or how to deal with data that comes and you don't know where the end of this data, when this data will going to end, and what to do with this. So making sense of this data. You can think about this, some of the like a quick streams, like you have some data that comes from your websites, or some of the information that comes from the mobile devices, and so forth and so on. And we want to be dealing with some of these things and how we can handle this. And typically, if I'd like to start talking about stream processing, I want to introduce the concept of event streaming platform. So essentially, it is for people who came from the messaging world, it sounds like very familiar. However, event streaming platform provides some of the different interesting capabilities that are not available in traditional messaging systems. For example, the persistency and the scalability and the ability to replace some of the streams of this data, and ability to not survive some of the failures of individual nodes. So the Kafka is the event streaming platform that's designed to be highly scalable, highly available system that, if you want, it can even be your system of record. In my opinion, when I talk to people who first time came into Kafka world, it is more like your NoSQL database with very special ways how you can access the data, rather than messaging system. Somehow, historically, some of the nomenclature and terminology that we're going to be using are highly inspired by messaging world. For example, data stored not in the tables, it's stored in the topics. But technically, correct word here is not the topic. Correct word here is a log, which is a sequence of events, the sequence of events ordered by time. And the Kafka is a system that managing those logs for you. Now, it's good that you have a place to store it. And the good thing is that Kafka provides the way how we can absorb a large amount of information that comes into. So Kafka is highly optimized for handling heavy reads and writes. But majority of the time, you want to read the data. And continuous computation, this is something that you will be doing always. So there's some application that will constantly reading data from Kafka, doing something with this data, and constantly writing data back to Kafka. And in this case, we're going to be focusing over the Kafka Streams, which is the framework that also built in Kafka and also comes with Kafka. So Kafka comes as a platform that allows you to store data, which you have our brokers, produce and consume data. It's some basic API producer and consumer, and also process this data. And what you will see later today, I hope that's my plan, is only show it's not only allows you to do things like processing, but also allow you to fully replace some of the service layer. For example, you don't need to have external database if you want to move this data after you're processing. And I will show you how we can do like simple REST service that also can do processing, but also can expose this data for the systems that don't talk Kafka natively. All right. That's high level. That's high level architecture. This is how it looks like. We have a producer. There's another component, which is like there's a Java producer. There's multiple different languages that implements this producer protocol that write data into Kafka, and the Kafka is Kafka producer handles like situation like load balancing and things like that. And there's Kafka consumer that can read data from topic, and multiple consumers, they can be organized in groups, and those groups can read the same data, and the data will not disappear after data would be acknowledged or received from the consumer. So that's one of the cool features of Kafka that's available, and we're going to be starting doing some interesting stuff right now. So as always, talk is cheap. Let's see some code, right? So we're going to the place that I personally love to start any project that I'm doing around Spring, around Kafka, because Spring Boot is fantastic tool and fantastic frameworks and fantastic community that allows leverage some of the modern techniques of software development, application development. And specifically, I like it because this toolbox allows me to focus on some of the important things and do not focus on not important things. So for example, handling configuration, handling all things around how to like deliver your application, how to package it. Like you can even like build jar, you can build Uber jar, you can build even Docker image, you can do like all sorts of things. And Spring also handles some of the like second day the production concerns, like exposing metrics, providing some of the ways how you can integrate this in your production monitoring environment and so far and so on. So, and today we're going to be doing a couple interesting things. So I will start with the with this starter, and I hope by the end of this session I will be able to build fully functional microservice application that will include multiple components. We will gradually build this while exploring some of the Kafka and Kafka Streams concepts. So essentially, in this session, is something that I will be using. Let's use just all fresh stuff. So that's my second favorite place on internet. If you want to go to developer.conf.io, it's a little bit of spoiler for some of the materials, but like, yeah, you can go there and check this out. This is the place where you can start your learning journey around Kafka. Let's call it Utah Geeks Streams, right? So I will be using Gradle. I consider myself as a responsible adult, so that like to make the poor life choices. And in my opinion, using Maven is a poor life choice. You can disagree with me, and if you want to disagree with me, find me in Twitter and let me know. Or after the session, I will take some questions, and you can argue about these things. So, couple things that we need to do. So we're going to be using this. So we're already here. So we're on the start.conf.io. We're going to be using Spring for Apache Kafka. This is a component that provides some of the basic integrations between Spring and Kafka. We're going to be using a thing called Spring Boot from Kafka Streams, since we're going to be using Kafka Streams. We're going to be using a Spring Cloud Stream. This is the most exciting part of this talk, in my opinion. The place or like thing, the framework and the tool chain that allows you to abstract out on all this infrastructure that you need to know and just focusing on implementing some of the logic. I think it's super cool. And I will be using, naturally, it's 2020. You need to use reactive. So I will be using this reactive app. It's going to be third part of this presentation, where we'll try to build the web service that exposes some of the information that we built. And let me check with my notes if I'm not missing anything. So we're good here. We're good here with CloudStream. We added Lombok. Lombok is a great library that allows me to focus on writing less. Whenever I write Java code, I like to use Lombok. Otherwise, I would just rather use Kotlin. And write down in the comments or like tweet at me if you would like to see this talk, but translated to Kotlin. This is something that I'm also excited about if you're interested in the future. So we do have a Lombok and we have a reactive web. So we do have these couple things, and we're going to be clicking generate. 2.3, yep, generate. All right, so also tweet at me if you got the reference that my terminal is like a terminal from Quake 2 specifically. It was my first Quake that I was playing. So and I do unzip Utah Geek Streams, and we're going there. And that's how we start. Bring my favorite IDE of choice. There are many great IDEs, but I prefer to use IntelliJ. And this is what we're going to be using today. Let me switch to a slightly bigger screen so you will see that we're going to be doing things. So let's focus on the like a small thing, enable annotation processor. So Lombok will also work. So we're going to be focusing on a couple small things. So first of all, we want to produce some data, and this is what my agenda item said. So we want to produce some messages to Kafka. So traditionally, how you can approach this, you will go and bring some of the Kafka dependencies and start the producer, and there's an API to send the message. Today, I want to show you something different that allows you to kind of like change the way how you would be building applications. So essentially, my applications are here. My Kafka, Spring Kafka, Kafka clients should be here as transitive dependencies that Spring Boot was bringing here. So if I would go here, say org apache.kafka, Kafka Connect clients. So we do have everything here. So we have our libraries, and this is good. Think about the Spring. When you start with the Spring, start the Spring.io, you will get all these libraries. So what are we going to produce to the cloud? I would use this small library called Java Faker, which is generate some random data, and let's put it somewhere. It's implementation, and I'll do. Can you show me what's the we have a Java Faker. Do we have it? Let's Google it. I don't remember what's the correct Maven Java Faker. And for Gradle, I think that should be, yep, that's developer-friendly documentation. So you can go in there, just copy the dependency, updating this thing. So we're good to go. And what we're going to be using today. So we're going to be doing some of the cool things. So the way how it works with the new version of Spring Cloud Streams, it actually supports the way how it can generate data by providing some of the functional interfaces. And if you're Java developers, you know that there is a kind of three, I would say, most important functional interfaces that available in the Java world since Java 8. It's supplier, it's a consumer, and function. So the difference between those, supplier provides the way how you can create some data or produce some data. So naturally, this method, this functional interface allows us to build functions that will be able to produce our data. So let's start with this one. So let's start small with this supplier. And our supplier will be producing these messages. And it will use this message from Spring Boot and from Spring. Where is it? Messaging, message. Yep, this one. So this message that will include some of this string payload, and we'll do produce something. So we will figure out what we're going to produce. And it returns supplier that needs to have something. And with this code, we need to create new message. Usually there is something called message builder that allows me to build this message. And with this message builder, I can do with payload that I need to generate some of the data. So with the Java Faker, I can get didn't updated my dependencies yet. Let's see if my GitHub Java Faker is here. Cool, in the house. So we will be switching here. Generate some data instance. And what kind of data will generate? So let's do something crazy like Chuck Norris facts about Chuck Norris. How cool is that? So we will be producing some messages in our Kafka topic that will include some of the text representation of facts about the Chuck Norris, which is like the awesome the character / internet superhero. That allows me to do this type of thing. So essentially, we will producing one fact at a time into Kafka topic, and in order to make it work, we need to annotate this fella with bin annotation. Now that's all from perspective of the code. Next thing, we're going into the world of that's known as a binder in Kafka or in the Spring Cloud Streams. So I will be usually I use application.properties. I prefer properties any day of the week, but today I'm going to suffer a little bit. So bear with me. I'm going to be using YAML. Application dot YAML. So, and with the application of YAML, just simply because there would be so many things, YAML would be much easier to navigate. So, couple things. So we need to enable this binder. So in this case, we will go into the Kafka Spring Cloud binder. So this is our binder, and we're gonna be doing configuring our producer. So we need to have a Kafka binder that allows this framework to write data into Kafka. There's multiple different binders available for different like messaging systems like Rabbit and for Solus and some others, but we're gonna be focusing on this binder, on the binder thing. So where's the producer properties? So producer properties, K serializer, and I will do in this one. So in order to write the data into Kafka, we need to specify this serializers that will take our Java object and turn it into byte. Kafka really don't care about what you store there, but your application does care. So the next thing that we need to do here is we need to provide some bindings. So we need to specify that what would be using this this framework, and in this particular case, our binding will be use this. Let's do produce. We need something with Chuck Norris. Chuck Norris is our guy. So we call it, the convention says that I need to specify name of the function. So in this case, the framework will look for this bean that generates this supplier for us. So I would say produce Chuck Norris. And I need to specify that it is writing data somewhere. So I need to say this is out. So it generates some data. And just index. Actually, I don't know reason for this. It's just like convention that probably you might have multiple beans that generate similar logic. So you need to know how to distinguish these bindings. And we need to say that we're going to be using Kafka Binder. And we need to specify destination. And destination is going to be our topic with facts. We can specify some of the parameters, producer. So for example, in order for us to use this serializer, because the Spring is so good that it provides you with all the serializers out of the box, I don't want to use like their out of the box thing. I want to use mine. So in this case, I will say use native encoding. Encoding. And the answer is true. And partition count equals 4. It's just the number of the partitions inside the topics in order to have this like a balanced load. We use this partition in the consumers and Kafka Streams. For example, Kafka Streams using this number in order to establish maximum number of parallel workers, like parallel tasks. Now, we're good with this stuff. Also, we need to put the information about Kafka, Kafka.properties, and one of the properties is bootstrap servers. And we're going to be using local host, just like because local host, it's so natural to use it. And the way how I can do this in a file, local services destroy. Let me make sure that I don't have any leftovers from my previous jobs. Okay, CNFL local services Kafka start. So you can ask me, Victor, what's the CNFL? What is this thing? What is it? Like what are you typing here? And I will do this CNFL, and it's a Confluent. It's Confluent CLI. The company that I work with, we develop all sorts of tools around Apache Kafka. We also develop sort of like a distribution of Apache Kafka. We call it Confluent Platform. I'm using here is Confluent Platform Community Edition that is like totally for free and stuff. It has the tools that allows me to start and stop and interact with this platform without need to run multiple scripts. So it knows that Kafka requires Zookeeper. It starts Zookeeper and starts Kafka, and everything is good here. Let's see if I have my topics. Topics. Let's see list of topics. It's running, so it's good in etc. So let's see if my application will be up to this task. So again, what we're trying to do here, we're trying to generate some of the messages that every second will be published into Kafka topic. So I'm going here and running this, and hopefully I didn't forget to include anything. And I did forget something. So let's see. Mapping values are not allowed here. Maybe that's why I don't like YAML. YAML has YAML is just like a nasty thing. See. That's why we don't have nice things anymore. Because like all this indentations things. So as you can see here, it's just like started here, working the way connected to Kafka. How I can see if I actually doing something? So first thing I will check if my topic was created. My topic is created. I can use console to read this topic, but what would be fun of it? It would be not, right? Hope you agree with me. So this is why we're going to be having another function that will be reading this data for us. So in this particular case, if we would be in the room, I would ask like, what interface, what functional interface would be responsible, would be better to create some of the data, or like process some of the data that has a method that can accept value and doing something with this. And some of you will say, hey, it's consumer. And you will be right. So we're going to do this consumer. Make sure that it is consumer, like a Java consumer, Java util function, not a Java client consumer. They are different. Conceptually, they the same, and we will be wrapping the Java, the Kafka consumer here. But this is going to be functional interface. We're doing like a functional programming, sorta, right? And we'll do consume. So, and in this case, it needs to get, so the consumer, we do have a function that gets this message. And what we need to do with this, we just do let's do something nicer. Where's my, no. Where's my cool wait a second, term, and there should be cool little, and there should be like something that allows me to do cool things. Term, like italic. Doesn't, no, it's okay. I do have it somewhere in my, no, I don't have it. Snap, yep, let's do this one. So we're getting this, we're gonna be at our message, and this is gonna be our payload. So what are we gonna do? This is just like a fancy thing that I want to show you around, that allows me to print some italic text in the console. I think it would be cool to have something nice in the console here. Now, and this is it. So this is my the consumer that will reading the message that we're just producing to this one, and also we need to specify binding for this one. So binder, we're doing this the consume Chuck Norris. So in this case, our binding, I apologize. In this case, was going to be in, so message will go into our code, -0. In this case, we also need to specify consumer group name. It's a mandatory parameter that available in that required for consumer group, for consumer to start. Sorry. We just do group, my group, and binder Kafka, and also we're using Kafka in this case a destination. So we need to specify that we're reading these facts. So that's pretty much it. Except I think I also need to provide a the consumer properties that will be specified. Consumer properties that key deserializer and the value deserializer. Just like same thing that we do with this. Okay, indentation. That's why we need to have a ruler. Like you don't see it here, but on my screen I have a ruler to know like I have a proper indentation. So now that should be enough. However, since we're doing these two functions in our application, by default it requires me to use just like one function, I guess. So it's why if I'm using more functions in my application, I need to specify how they will line up. So in this case, I'm going. So in the Spring Cloud Stream function definition, so I need to say like what's going to be sequence of this function. I can pass one of the, it's how I can specify like sequences. So in this case, produce Chuck Norris, it's going to be our first function, and it's going to be second function. So that should be enough. So if I go ahead here and we'll go and restart, and remember, when I start producing these messages, I was not, my consumer was not running, but because the messages are in Kafka and the Kafka allows me to read the messages even when I was offline, my consumer should start reading these messages, stop and rerun. So let's see if this will continue to successfully work. And do we see anything? No, we don't see anything for some reason. And the reason for that, I do have this bin annotation here. And I do have methods here. So let's see if I have a consumer, so serializer, but deserializer. So it looks like my configuration for consumer did not pick up. So let me see what I'm doing this, why I'm doing this wrong. So let's take a look on this one. So consume bindings, Chuck Norris. Just want to make sure that I'm doing this. Consume Chuck Norris. Just copy pasting errors always huge problem during the live destination facts producer. That should be fine. Consumer, yes, that's my copy pasting error. So let's restart this, and now we are golden. We're golden. No. Should we start seeing some of the messages? So our partition assigned. No. Can we see some messages, please? Can we see some messages? Let's go to console and see if there's actual messages. Consume facts. Are there any? Looks like I'm not producing for some reason. There's no data here. Let's figure out why it's not. There's no messages in a topic. Let's see. As with load build, yep, that looks great. Looks fine. And it's a bin. It's a supplier. It's a produced message. Writes a topic. Let's see configuration, because I might produce Chuck Norris. I might also type is incorrect. So we do have this function definition, all good. We're looking into right things. Function definition bindings. Produce Chuck Norris, consume Chuck Norris. Even though looks like even from the very beginning, it was not producing. So let's see what was the problem. Maybe I'm doing something wrong in this code. Message bin. Okay, let's see if our producer doing something right. So let's take a look on the output. So it was successfully created, consume and produce out. It's input and output. It was created. Topic was created in localhost. We see this topic, producer works. But what is wrong with the message? Let's see. Maybe I messed up with the API here. So let's do old way. New faker, and in this faker, I'll just do variable and faker. Chuck Norris. Okay, cool. So in this case, I will be using my faker here. and I'll do Chuck Norris dot fact. Okay, so that should do. And nothing is happening. Nothing is happening for some reasons. Let's see if we still don't have a data in my topic. Yeah, so the data is not there for some reasons. My producer is not producing data, which is really, really weird. So that's all right. Let's figure out. So in a usual setting, like if we do this in the world of the facts, that's what happening. Usually, usually people in the audience will be helpful to provide this saying, hey Victor, you have a typo here, once we had this running, I will give you a moment of your time to speak up a little bit. Here we go. Nice. So we have some of the errors, but what is happening with the errors? But at least we switch from the mode where dispatcher has not described its application. Application check noise out, nested exception. Dispatcher no subscribers for channel. Application.produce check noise in out. It can be true. It can be true. Let's see if we have our data. Data should be here, but it's not. Let's just check this again. So we're writing this data into this topic, and this is what we're doing here. We do have, I'm wondering if the position of this guy is actually correct. So Kafka stream, like this one, something like this. So, and in this case, it should do bindings correct. Consumer, producer. Okay, let's rerun this. It's always funny when we're dealing with YAML, and right now you see I'm spending more time to to figure out what is wrong with my configuration than I actually do anything. You know what? It's always good to be prepared for this type of situation. So that's why I have some YAML that already is working. So I will try to just replace it, and we will go through this one afterwards. So let's see if it's actually working, because I do have some exciting thing to show you in the next couple. No subscribers. Why? That's weird. Produce Chuck Norris. Let's see. My methods should be all right. So let me finish then. I will try to. Now it always happens. It's a that's really good code that should work. And why it is not doing this, I don't know. But bear with me. We will get there together. So while it's not working, I might answering some questions. Trust me, it did work like moments before this presentation. So I don't know what is happening. Soraya, do we have any like questions maybe in the meantime when I'm trying to figure out what's the problem and I can stall and answer some questions?
Sure. There's only one question so far, and it says, what about a .NET demo?
Nope, no .NET demo, because there was a Spring Boot demo. There is a plenty of demos. You can find this if you go to GitHub repository called Confluent Inc/examples, and there's a plenty of examples for all sorts of languages. You can find this .NET, you can find Rust, you can find Clojure, you can find Kotlin or whatnot. So there are plenty of these if you go to this one.
And that's all the questions we have for the moment.
Yep, cool. All right. Do we have any people there at least? Like, do we know like if people actually watching?
Yes,
yeah,
there are
so
definitely people.
Yeah, so there's what I was talking about. This is like a C#, there's Groovy, there's Java, there's a Python, Node.js, Rust, Scala, what have you. So all these examples are here, and this is repository that you want to bookmark. All right, so let's see what I'm doing this wrong. Dispatcher has no subscribers for the channel. So let's see. Bin, application YAML. And let's see if I'm doing any typos in produce check noise. So to do this, that's all right. Out 0 binder Kafka facts producer, partition count. That should work. And producer, we don't need to do process words yet. We'll get back to this one. Function definition. We don't need this for now. Producer. That's really weird. Never happened with me before. Says no one. Still nothing. Still nothing. Let's see if I'm using right fact. Yeah, there should be Kafka, my group. Yeah, that should be correct. Consumer, and my consumers also needs to be. Let me try to use this one more time. And my code should be also the same. That should do. Now I wouldn't like copying like existing code that definitely worked before I started. Something is wrong with my computer. Maybe I broke something in meanwhile. Right. So I will skip this part. So I will try to like talk a little bit about some other stuff, but I will get back to this one. So let me just remove this. So I would like to talk a little bit about the framework that has built-in capabilities to do some processing. That is called Kafka Streams. So Kafka Streams is the Java library that allows you to do scalable, elastic, fault-tolerant, stateful, and distributed stream processing. So in this case, like if you've ever been in the world of distributed computing, if you need to calculate something and you need to run something, you need to bring some of the things like Storm or maybe Hadoop or maybe some Spark and some other things. But Kafka Streams is not like that. Kafka Streams is just a library, just a library that is built into Kafka. It's just a Java library that you can just take and start using this. And the way how it looks like is just like your application connected to this Kafka cluster and constantly reading data and writing data into a Kafka topic. And after that, that you can scale this out, and nothing is runs inside the Kafka broker. So this is the cool thing, that you can scale those independently. If you need to scale your application and do more processing here, you just need to spin up more instances of Kafka Streams application, and still there will be no things that runs inside the broker. And so this allows to do like things like this. So we're fully changing the way how we interacting with this world. So previously, like when we want to have things like the processing something, we need to build a cluster of the processing things. So for example, Spark cluster. After that, we need to submit our job somewhere. So in this case, it will submit the job. This job will be running somewhere. Now you need to have some coordinator that will be checking if this job would be up and running and things like that. So, but we don't need to do this with Kafka Streams. With Kafka Streams, we just simply dealing with the one simple thing. And this simple thing is just the built-in app. So this application, this application will be constantly reading data. This application will be constantly consuming data from this Kafka topic, and all stuff will be happening inside your application. So there would be no other things that you need to do. And the cool thing about this, it's rather powerful. You can deploy this everywhere you want, and like you can use like any cloud, you can use any deployment technology that you'd like to use, and so far and so on. So this is really powerful, and I think this is something that many people usually miss in the world of the modern systems, where like you need to go through many different hoops in order to have this application up and running. So so yeah, that's Kafka Streams. And let me try to also like finish this example, and maybe demo will be up and running. If not, I think I have idea how I can make it up with you, because I do some other things in internets, like doing some YouTube streams where things actually work somehow. But yeah, so the Kafka Streams is a library that already have built-in capabilities to deal with the unlimited streams of data. It has the ability to build like a windowing functions. So in this case, this functions will create the finite kind of, you can create like a small boundaries for your stream data. For example, if you need to calculate some of the messages over time, running average within 5-minute window, and like every time you will get like every 5 minutes you get some of the result. Like you don't need to have a result like every second, but like after 5 minutes you will get a different result. Sometimes it's more than enough for stream processing. Sometimes you don't need to wait until the end of the day. You just need to like what was our stats, what our sales for the last 5 minutes, like if we sell something like very hot. And so yeah, so let's switch back to demo, and we'll try to one more thing. Maybe this will work then. So I'm getting back here. So let me do let me start by like wiping up, because usually maybe there's some of the things still stuck somewhere, and I'm maybe missing something. And I can do services. Start Kafka. Let's try this one more time. Now I do have a slightly I did a slightly update of this one. Let's see if this will work finally. If it's not a big deal. I will find this and we'll push it. Yep. So apparently something was wrong with my Kafka setup. You see, my consumer is finally reading some messages from Kafka topic, and I can also do this from just standard console tools, and I get these results. Now let's talk about this stream processing library. So the way how the stream processing thing works is actually you building a Java application, you're building Java topology here. Let me just quickly remove this one, how I can remove this one. And anyway, so Kafka Streams allows me to operate and creating this abstraction on top of Kafka topics that called streams. So in this particular case, with the power of Spring Cloud Streams, I actually injecting this stream based on this configuration. If I'll go here in my binding configuration for my Kafka Streams binding, I'm saying that this is going to be my input. This is going to be topic that I'm reading from, and this is going to be topic where I'm writing data to, right? So in this case, I will have this. Let me just remove this guy. I will show you this at the end. Now, okay, so we have a controller. We'll do this one. Now, we're reading data from this input stream, and now I'm just using just like Java, similar Java methods to Java util streams. I turning every message. I'm splitting every message here on words, and after that, I'm creating another stream. So this stream will include every message will include just one word. So I'm getting stream of sentences. I'm breaking this down in a stream of words. Now I want to map it. I want to transform it in order to get make count, like the make word as a key for my processing. So in this case, I'm extracting this key. This was going to be a particular word. And after that, I'm grouping by key. So in this case, my results will be grouped by particular word. And after that, I can do this thing called count. And in this case, I will get the result. Let me actually remove this real quick. And I will show you how does it work. So this is this application that will reading some of the things from Chuck Norris's quotes and providing some of the counts information. So my producer will produce, my consumer will consume just for the sake of outputting this to the console. But if I will do this, if I have a consumer that creates the counts, my values would be long value, and my keys will be string. So if I will run this, we will see pair word and count, word and count. So that would be enough for some of the systems to get this result. You see this, these numbers, you can see it like 2 times and things like that. And the reason for that is that we're getting streams of counts. So there's no way how we can accumulate this because we're getting this data in the topic and they're reading the data into this in the console. So the way how we can make something that will be consumable, remember, let me show you this picture once again to remind you what I was going to be talking about. With this picture, with this streaming platform definition, we all only build this part. We only build the part where we are, I'm sorry, just a little quick, fat fingers. So I will go and show you. So we build this part that does computation, but we need to also build this part to serve this data to external system. The simplest possible way is to use external database and dump data to external database. There is a API that available in Kafka, this API called Kafka Connect. And Kafka Connect allows to just like write a configuration file, and there would be connector that will suck in data out of the Kafka and put in the database of your choice. But we can do this better. We can do this better because Kafka Streams provides the way how I can access to this storage of this information, kind of like using the built-in database. So in order to do that, in my count, this is where my result would be stored. I need to put this thing called materialized. So with this API, the Kafka Streams will create the small database that will run inside this Kafka Stream process. And this database will be available for querying this data through key value. So in this case, I will be able to create a web service inside my application that I can access to this data, and I can expose this data to outside world. So for example, if there is some systems that don't know how to read data from Kafka, they can come and do this. It's called the feature called interactive queries. So I will just controller. We'll do the REST controller. Another thing is that I want to private final interactive query service, Q service. So this interactive query service allows me to access to these state stores that are available in my application. So I need to have a required argument constructor that will generate a constructor for this method, and Spring Boot in Spring will be able to inject a public, let's say, count. It's going to be long, and get count, get mapping for our method. We're going to be using /IQ /word, and we're going to be doing this one. Count, and they're going to be doing this word as our parameter. So in my code, what I can do here, I will be using this API to access to this state store. So essentially, in my code, I will do IQ service get queryable store store name. We know this because we call it like this. So inside your application, you will have automatic materialized view that will be queryable store types. Queryable store types, and with this type, I will have key value store, and I'll just do variable, and my store is going to be string because it's our word, and the long because it's our count. Get store dot get, and the key is going to be word. So when I restart this, stop and restart, my application will contain 3 parts. It will contain the producer that will generate some data. It will contain consumer that will just simply dumping this to the console. It will continue to do constant processing using this Kafka Streams application, but also it gives me ability to query this with things like I do IQ. What's the parameter? I'm using this one. Count word. So I do IQ count, and what word, like roundhouse. How many times we have a roundhouse in the word? We don't have it. Why? Why it's a roundhouse? Because probably I'm typing this wrong again, probably. No? Let's do check. 86. Norris 90. So we do have some of the data that is available. Previously, we didn't have this store. We just created the store, and some of the data that we reprocess, we didn't reprocess it. We need to reset the offset in order to reprocess this data. But and that's going to be doing this right now. And you see this count is changing. Count is counting, going higher. So in this case, I think application works. Finally, whew, application works, and thank you very much. That's hopefully you were a little bit blown away with the capabilities that are available there. We had this little bit rough start with some of the copy pasting errors, but hey, we finally get into the point. If you want to learn a little bit more about this, we build a whole website for people who wants to learn Kafka. This site called developer.confluent.io. If you will scan this code, and you will get the link to this website, and you will start learning things around Kafka. Another thing that is a part of developer.confluent.io is a website called Kafka Tutorials. It is something that my team is actually working, and this is approach with this website is rather than we're focusing on use case. You want to do something like you want to do like filtering stream of events, or you want to do count of number of messages, or you want to use some of the hoping messages or hoping windows or sliding windows or whatever, or you want to use Connect. You want to go there and go step-by-step instruction, and you will learn how to use Kafka. With this, thank you very much for your time, and I really appreciate whoever stayed until this end. You can find me in Twitter. My Twitter was conveniently placed in the bottom of every presentation, every slide. I will bring this back a little quick. If you want to reach out to me, you can always come to this website called Twitter, and follow Confluent for all Kafka and Kafka Streams and all stream processing updates. But yeah, that's it. And I would turn to Soraya if we have any questions from the audience.
We do have questions, Victor,
Nice.
but unfortunately we're at time. So
Yes.
Would it be okay if folks reached out to you via your contact info to
Absolutely.
ask
It's like, yes, we don't have a time for Matt Damon today, so that's totally fine.
Right. Thank you so much for your presentation, and thanks everyone for joining. Have a good day.
Thank you everyone for joining, and I hope we'll see you next year in person. Bye.